In this video, we delve into the pressing challenges faced by nations heavily reliant on renewable energy sources, focusing on issues such as blackouts and grid instability. As countries transition to greener energy, intermittent energy supply, energy storage limitations, and grid overloading become critical factors to address. Join us as we explore the complexities of maintaining a stable power grid in a renewable-heavy landscape and examine real-world blackout examples that illustrate these vital concerns. Let's uncover how demand-supply mismatches and the reliance on fossil fuel backups impact our energy future. Intermittent energy supply. Renewable energy sources, such as wind and solar power, are renowned for their clean and sustainable nature. However, they come with an inherent challenge: intermittency. Unlike fossil fuels, which can be burned on demand, renewables rely heavily on weather conditions. For instance, solar panels only generate electricity when the sun is shining, and wind turbines stand still when there's no breeze. This dependency means that energy generation can fluctuate wildly throughout the day or even over the course of a year. Such unpredictability contributes significantly to grid instability. Imagine trying to power a city with a flashlight that only works when the sun is shining. It's a daunting task that requires clever solutions to ensure a consistent energy supply. Energy storage limitations. One of the primary solutions to counteract the intermittency of renewables is energy storage. However, many nations leading the charge in renewable adoption lack the necessary large-scale storage capabilities. Advanced batteries and other storage technologies are still in developmental stages or are prohibitively expensive for widespread use. Without these solutions, renewable energy remains unreliable during periods of low generation, such as cloudy or windless days. It's like trying to save rainwater in a small bucket during a drought. The capacity just isn't there to meet demand when nature isn't cooperating. This storage shortfall is a critical barrier to achieving a stable renewable energy grid. Overloading of grid infrastructure. As more individuals and businesses install decentralized renewable energy systems, like rooftop solar panels, the pressure on existing grid infrastructure increases. Many grids, especially older ones, were not designed to handle the two-way flow of electricity that these systems introduce. This can lead to grid overloads, resulting in blackouts in areas that haven't received necessary upgrades. Picture an old bridge suddenly having to support twice the traffic it was designed for. Without reinforcements, it's only a matter of time before it fails. The integration of renewables requires significant investment in grid infrastructure to prevent such failures. Reduced spinning reserves. In traditional energy systems, fossil fuel plants contribute spinning reserves, which are essentially power plants running below capacity that can quickly ramp up production to meet sudden surges in demand or drops in supply. As nations shift towards renewable energy, the number of operational fossil fuel plants decreases, leading to a reduction in these reserves. It's akin to having fewer standby backup generators ready to jump into action during a power outage. Without these spinning reserves, the grid becomes more vulnerable to instability as it loses the ability to swiftly respond to unexpected changes in supply and demand. Voltage and frequency. Fluctuations. Renewable energy sources can introduce significant irregularities in both voltage and frequency within the power grid. Unlike traditional power plants, which can be finely tuned to maintain a steady output, renewables are at the mercy of nature's whims. These fluctuations can lead to power quality issues, affecting everything from household appliances to industrial machinery. It's similar to trying to watch a movie on a streaming service with a shaky internet connection. The experience becomes frustrating and unpredictable. Maintaining consistent voltage and frequency is crucial for the health of the grid and the equipment connected to it. Demand-supply mismatches. A major challenge for renewable-heavy grids is balancing demand and supply. There are times when renewable generation peaks during periods of low demand, such as a bright, sunny afternoon when most people are at work. Conversely, during peak demand periods like evenings, renewable generation might be low. This mismatch creates challenges in efficiently utilizing the generated energy and ensuring adequate supply when it's most needed. It's much like having a feast ready when no one is hungry and then running out of food when everyone shows up. Effective management and forecasting are essential to addressing these mismatches. Reliance on fossil fuel backups. Despite the push for renewables, many nations still rely on fossil fuel plants as backup sources to prevent blackouts. These plants are kept operational to provide power when renewable sources fall short. While this strategy helps maintain grid stability, it undermines the environmental benefits of renewables by keeping high-emission facilities active. It's like trying to quit smoking, but keeping a pack of cigarettes in your pocket just in case. This dual infrastructure approach not only increases costs, but also complicates the transition to a truly green energy grid. Blackout examples. Several regions have experienced blackouts or narrowly avoided grid collapses due to their heavy reliance on renewable energy without adequate backup or storage solutions. Germany, California, and South Australia are notable examples. In these areas, high renewable penetration combined with inadequate infrastructure and storage has led to significant grid instability. It's like building a city on a foundation of sand. Without solid support, the structure is prone to collapse. These instances highlight the urgent need for comprehensive solutions to ensure stable, reliable energy in renewable-heavy nations.